Okay, so we're going to look at wave instancing now. If let's say I have a large ocean, we'll do 1,000 meters by 1,000 meters. Not that large in the grand scale of things, but for the sake of this, we'll say it is. Our grid size is 50. As previously sort of touched upon, you get these weird repeating tiles patterns, and that's obviously not good. We don't want that. We could try and combat that with some masks, but the issue is whenever your sort of seam of where the tiles meet, you're still going to get that kind of like reset of the new tile. So a way to sort of beat that is to do wave instancing. And like anything in Houdini, when it comes to instancing, we need points. So if I place a scatter down, I'm going to just keep 100 for now and have them randomly distributed like this. And if we go to the ocean spectrum, you'll see there's two inputs. There's a mask on the right and the instancing point on the left. If we plug our scatter into the one on the left and view what that does, you'll see it actually instances waves only where our points were. So if I take it off, it's everywhere. Here is where our points are. So the first tab is, the first parameter is radius. This is essentially how far out from my point that I give you do you want me to instance waves onto. So if I increase this to something like 50, you'll see that the coverage increases. And I obviously could do that backwards as well. It's useful because you can also have a varying radius. If I reduce that to 10 and have a variance of 50, you'll see that straight away that some actually have a much larger radius than others. This is basically just a random standard deviation of you can have up to this amount extra on my radius, which is useful if you're just trying to make a more random scatter or instance. For a generic kind of like, I want these waves everywhere, I'd have variance quite low. That way you get a more consistent coverage. But if you're doing more, like a bespoke layer, like I want these large frequencies not everywhere, but some places, then variance really would be quite useful there. So radius, obviously, we could increase this to something like 200 and it would cover everywhere. The issue is you're going to get like some overlapping, especially if the points aren't particularly uniform. So if you want a generic kind of uniform scatter, I would have a decent amount of points and I'd keep relaxed iterations on. Again, if you're doing something like a bit random, you can turn them off and you can get like little clusters of a scatter. But for this case, I'm going to have it fairly uniform. I don't want to iterate its relaxations too much, because what I can do then is if I set a radius to something like 10, we get a general coverage. If I increase this to 30, you'll see that we're getting overlaps, which is basically the waves are being scattered on top of waves, which is why the amplitude seems a lot higher. Whereas if we reduce that down and keep that somewhat coincide with the general like distance from our points, we'll get a more consistent coverage and less like flat patches and more importantly, less overlapping waves. You'll still get a couple unless you do like a really consistent scatter, but for the sake of like an ocean, I think you can still get a natural view by doing this. So that is kind of the radius aspect of things. And I'll just quickly show you, this is with instancing, this is without. So it's the same kind of waves because it's the same spectrum, essentially. There are some parameters here that are changing it slightly, but we'll talk about them in a second. We're eliminating those weird grid lines that we get if we didn't actually instance. So it looks a lot more natural. It means that we can have an infinite ocean and we don't get these tiling issues that we don't want. So that's radius. Next would be rotation, which is essentially direction. As you can see here, the direction is set to 0, which is along the x-axis, which is going straight up in our case. If I go to our clock camera, you'll see that it's going up. I'll zoom out a little bit because of the size of the ocean. I can also set the rotation to be 90 here, and it will actually change that to be go to the right, which is 90 degrees on our compass. The variance, similar with the radiance, is the same idea. If I set the rotation to 0, i.e. match what it was at direction, we can say the variance, okay, randomly, some of you can go to the right, but some of you can also go to the top. Obviously, that's a little bit hard to see because it's all gets mushed up into one. But this is really useful because it means we can have a per point direction. So we can actually feed in like a normal with our scatter points. Let's say if you paint a river, you work out the directional vectors of the river, you can have varying direction on your points. So rather than if you've got a wiggly river, your your waves wouldn't just move straight like this, would it? It would like hit the waves, it would change, the current would take it. So by having that varying normal direction, you can achieve that with a spectrum, which is really handy. You can obviously disable that, and it kind of would just use the default here. That's not the case with all of them. If I turn amplitude off, we obviously get nothing. But it's useful with that rotation. But for the most part, you could just match that with, you could even reference that here like that, and then just keep the variance. So if you want to be super safe, there's an option for you. So amplitude is kind of self-explanatory. This is a multiplying factor. Let's go with that one. On the amplitude that we set on our base waves anyway. So if I change our base amplitude anyway, like to double, it would change our instance waves as well. But the waves instancing, we can basically change the variance. So if I have amplitude 1, variance 0, it's essentially the same amplitude as if I wasn't instancing. Obviously we get some overlaps, that's why it's not super uniform, but it's just something, it's another option we can change. Again, per point we can have some really high, let's say 10, and then let's reduce that 0.5. You know, you'll get some that are high, some that aren't. But for the most part, I'd probably say just a little bit of variance is fine. But have at it what you will. It's your choice. Offset is just an offset of the wave. Again, I don't really care for about having an offset on this because they're a bit randomly scattered anyway. We're not going to get these super grid-like patterns, so it would look fine regardless. And then you have the option as well with like wavelength here, but I mean it's off by default. I've never really turned that on ever, so I won't worry about that either. And then roll off is basically when it gets to the edge of our radius per point, how fast do you want me to roll off this wave? So if I say 0, if I go slightly, you'll see that it's really it's like a gradual fade off. If I reduce this to 100, and let's increase this radius a little bit. This might be a little bit hard to demonstrate. You'll see that it's like, let's say this is our center, and then this is our distance. We're really trying to fade it off really slowly. Whereas if I set it super high, it's going to get as close as it can, and then just end really quickly. So think of that as almost like a ramp of how far from the point to the radius end do you want the wave to roll off. Again, if you've got enough radius and enough points, it probably won't really matter what you set this to, but you could go 10 if you want it to be a bit more sharp, or a bit lower if you want it to be more ramped. The choice is yours. So that's the premise of wave instancing. I'm going to talk about how you can kind of bias some normals now. Alright, so let's talk about how we can kind of change the directionality on a per point basis. So at the moment they're all going, that waves are all facing the same direction, which is positive x, because our direction is set to 0. For the sake of cleanliness, I'm going to set a vector to be that as our incoming normal. As you'll see, nothing will change here. We're still going in the same direction, and I'm also going to up the directional movement unbiased, so it's a little bit more clear that we're all still moving this direction here. So what we're going to do, we're going to draw a curve. This is just one way of doing it, just to demonstrate how you can change the normals. And I'm going to draw a curve going the opposite direction of our waves. I'm going to resample said curve, and I'm going to enable tangent and just change that to normal. So this gives us now a vector, there we go, pointing down our curve, which is, if you remember, is the opposite of what we just hard-coded here. So if I go back to our ocean here, you'll see they're all going the same way. If I then actually transfer our normal from our curve to our points, and let's increase the distance threshold maybe like this, you'll see you could also blend width, I guess, which will give us a little bit of a cleaner transition. Because in fact, we'll do without blend width now, I'll show you why. And then I input you like that, you'll see straight away something happened. Just to demonstrate it again. That's because we now have some going upwards and some going down, which are in the shape of our normals we've given. The issue is when we do it such like hard like this, the actual transition between the two just doesn't really make sense. It doesn't make too much sense that two streams will be going directly opposite each other anyway. But like here, it just looks a bit janky, which is why with like a blend width instead, it would essentially attribute blur it almost, and it'll give you a slightly more reasonable transition between the two. This would probably work better if like you had a really still spectrum in areas and then a moving current through, kind of like when you think maybe at sea when there's like sediment volume there, it doesn't really move, but the actual ocean does around it. This could be quite useful for that. But yeah, this is just an indication of how you can kind of adjust the normals to change the direction of your points. You have varying ones on that. This is probably a little bit of an extreme example, but you could obviously, rather than just, I don't know, how could we do it? We could actually transfer color maybe onto our, I'm going to be really quick with this, onto our grid. Let's say that's black. We want CD only. Let's increase that. And then what we could do is we could obviously still have our normals be what they were, but we only scatter points here now instead. That way, you know, we can still get our normals, but only where we want them to change, rather than rely on everywhere. Just an example. Thought I'd include that. It can be really handy for like rivers or currents. There's another way where you can like kind of like point deform your base, but for the most part that can kind of be overkill, especially if you blur your values a bit so it's not super rigid. You can get away with this and it's a lot quicker and easier to do. So yeah, hopefully that's useful.